Space is vast, really vast. It's a realm that stretches beyond our wildest imaginations, a boundless expanse that seems to go on forever. Imagine the biggest thing you can, then multiply that by infinity. Even then, you might only begin to grasp the sheer enormity of the universe. That's closer to the scale of the universe. It's a place where distances are measured in light years, and even the speed of light seems slow. In this immense cosmic arena, filled with swirling galaxies and twinkling stars, there are wonders beyond our comprehension. Our planet Earth is just a tiny speck in this vastness, a mere dot in the grand tapestry of the cosmos. But this speck is incredibly special, a vibrant oasis teeming with life. It's a unique haven where countless ecosystems thrive in harmony. However, it wasn't always this way. The Earth we know today has undergone a dramatic transformation. To understand how Earth became the life-sustaining world we know, we need to journey back billions of years to its fiery birth and the remarkable chain of events that followed. This journey takes us to the very origins of our planet. Our story begins long before our sun ignited in a cloud of gas and dust called a nebula. This nebula was a cosmic nursery, a place where stars are born. This nebula, a remnant of long-dead stars, held the building blocks of our solar system. It was a chaotic mix of elements, waiting to be shaped by the forces of nature. Gravity, the architect of the cosmos, slowly pulled this matter inward. It acted as a cosmic sculptor, shaping the raw materials into something new. Over eons, this cloud spun faster and faster, eventually collapsing under its own weight. This collapse set the stage for the birth of our solar system, a process that would take millions of years to complete. As the nebula contracted, its center grew denser and hotter. Temperatures soared, reaching millions of degrees. This intense heat and pressure triggered a nuclear fusion reaction, igniting the core of our newborn sun. The sun's birth wasn't a peaceful affair. It unleashed powerful solar winds that blasted outward, pushing away the remaining gas and dust. However, not all the material was expelled. Leftover particles, remnants of the nebula's collapse, continued to orbit the young sun. These tiny particles, through a process called accretion, would become the seeds of planets, including our own Earth. Imagine a cosmic dance floor filled with dust grains colliding and sticking together. That's how Earth began to form. These collisions, initially gentle bumps, grew more energetic as the clumps grew larger. Over millions of years, these accumulating particles formed larger and larger bodies called planetesimals. As planetesimals zipped through the early solar system, their gravitational pull attracted even more material. Like cosmic vacuum cleaners, they swept up surrounding debris, growing larger and larger until they reached the size of planets. This process of accretion is how Earth, a hot, molten ball of rock, was born. The early solar system was a chaotic place, with collisions being commonplace. Shortly after Earth formed, a Mars-sized object slammed into our young planet. This impact, one of the most significant events in Earth's history, blasted molten rock and debris into space. This debris, caught in Earth's gravitational pull, didn't drift away. Instead, it coalesced over time, forming our moon. The moon's formation wasn't just a cosmic spectacle. It had profound effects on Earth, stabilizing our planet's tilt and creating the tides we know today. Section 5. From Fire to Water, Shaping a Habitable World. The early Earth was far from hospitable. It was a hellish landscape of molten rock and volcanic eruptions. Over millions of years, Earth slowly began to cool. This cooling allowed the molten surface to solidify, forming the first crust. As Earth cooled further, water vapor released from volcanic eruptions condensed in the atmosphere. Torrential rains fell upon the barren surface, forming the first oceans. These oceans, covering much of the young Earth, would become the cradle of life. Section 6. The Spark of Life. A Cosmic Mystery. The origins of life are shrouded in mystery, one of science's greatest unanswered questions. How did life arise from a primordial soup of chemicals? While we don't have all the answers, scientists have proposed several intriguing theories. One theory suggests that life arose in shallow, sunlit pools of water, where organic molecules, the building blocks of life, could concentrate and interact. Another theory proposes that life originated in the depths of the oceans near hydrothermal vents, which spew hot, mineral-rich water into the ocean. Section 7. Life finds a foothold. The first organisms. Around 3.5 billion years ago, life emerged on our planet. The first life forms were simple, single-celled organisms called prokaryotes. These microscopic pioneers thrived in Earth's early oceans, far different from the oxygen-rich world we know today. Evidence of these early life forms is preserved in stromatolites, layered structures formed by colonies of photosynthetic bacteria. These ancient structures, some of the oldest fossils on Earth, provide a glimpse into the dawn of life. Section 8. Oxygen. A game changer for life. For billions of years, life on Earth was confined to the oceans, existing in an atmosphere devoid of oxygen. These early life forms were simple, relying on anaerobic processes to survive in a world that was vastly different from the one we know today. However, around 2.5 billion years ago, a dramatic shift occurred, the Great Oxidation event. This monumental event marked a turning point in Earth's history, fundamentally altering the planet's atmosphere and the course of life itself. This event, triggered by the evolution of photosynthetic cyanobacteria, flooded the atmosphere with oxygen. These tiny organisms harnessed the power of sunlight to produce oxygen through photosynthesis, gradually transforming the environment. This oxygenation of the atmosphere had profound consequences. The increase in oxygen levels not only changed the chemical composition of the air, but also set the stage for new biological possibilities. It paved the way for the evolution of more complex life forms that relied on oxygen for respiration. Multicellular organisms began to emerge, diversifying into a myriad of forms and functions. It also led to the formation of the ozone layer, shielding Earth's surface from harmful ultraviolet radiation. This protective layer allowed life to thrive on land, opening up new habitats and evolutionary pathways. Section 9. From simple to complex. The rise of eukaryotes. The rise of oxygen in the atmosphere set the stage for a major evolutionary leap, the emergence of eukaryotes. Unlike prokaryotes, which are simple, single-celled organisms, eukaryotes have a distinct nucleus and other membrane-bound organelles. This evolutionary innovation allowed for greater complexity and specialization within cells, paving the way for the evolution of multicellular life. Over millions of years, eukaryotes diversified, giving rise to the incredible variety of plants, animals, and fungi we see today. Section 10. A Tapestry of Life. Diversity and Adaptation. From the depths of the oceans to the heights of the Himalayas, life has colonized virtually every corner of our planet. Each ecosystem, whether it be the dense rainforests, the arid deserts, or the icy polar regions, hosts a unique array of species that have adapted to thrive in those specific conditions. This incredible diversity is a testament to life's remarkable ability to adapt and thrive in a wide range of environments. The variety of life forms, from the tiniest microorganisms to the largest mammals, showcases the endless possibilities of evolution. Some organisms have evolved to withstand extreme temperatures, from the frigid polar regions to scorching deserts. Polar bears, with their thick fur and fat layers, are perfectly suited for the Arctic cold, while camels, with their water-storing humps, are built to survive the harsh desert heat. Others have adapted to life in the absence of light, relying on chemosynthesis instead of photosynthesis. Deep-sea creatures, living near hydrothermal vents, harness chemical energy from the Earth's interior to sustain themselves in complete darkness. The story of life on Earth is one of constant change, adaptation, and diversification, a testament to the power of evolution. Over millions of years, species have evolved, adapted, and sometimes gone extinct, leaving behind a rich tapestry of life that continues to evolve. From its humble beginnings in the primordial soup, life has transformed our planet into the vibrant, life-sustaining world we call home. The journey from simple, single-celled organisms to the complex web of life we see today is a remarkable testament to the resilience and adaptability of life on Earth.